Hello there. Today we'll be doing partition labels. This is going to be another greedy problem in our Neetcode. This is our 115th problem. Okay, in the partition labels, what we're trying to do is grab every section of the string that has each character that exists. So what does that mean? That means that we're going to split this up here, and we're going to split this up, here. Yeah. So the reason why we split this up in, sorry, my bad, here. So the reason why we split this up this way is because the A started this item, and we're closing it with an A. We started this with a D, but we also have an E in this section of the string. So we close with an E. There are no I's or H's. If we started an H and I, so we must make sure that we close the H and I's and a J as well. So we must close with a J. At this point, you might think, okay, maybe we can do a stack. By using a stack, we could throw items into the stack, right? And remove them and add them in and remove them. But the problem is that we will lose all the A's here. We won't know when we'll lose all the A's. Just because we see an A doesn't mean we lose it either. We also have a B here. So that's not a very good option. What we would choose instead is to store all the last index of each character we see, and once we get past that last index, that means that our I passes that last index. That means that's the last item for all the characters, and that's a partition. Here's what I mean in exact terms. So let's say here is a pointer. I'm pointing at A, and my last index of A is equal to that last index here, which is like 8. And as I move along, I change my last index to the point, and then I reach it, and I have one partition. Then I do it again. So I have D, my last index is here, and I have E, my last index is now here at that E, and I keep moving until I reached it. Okay, then I have a second partition, right? Then I meet this third one, right? I don't know where that is, maybe like 15 or something, let's just say. And then we find that H is here, that's like 18. We keep moving, 19, and then 18, 19. And we keep moving until we hit the index and we're good to go when we have 3 partitions. And we store the size of these partitions and we return them. And so let's do that. So first things first, let's create the last index dictionary, which is going to have a key of character and value of like the last index of character in string, and let's enumerate that. So this updates the particular character with the last index, and the last item would be that particular index. So we create the array, create the size, create the last item, and for I and C in enumerate of S, we're going to set the size plus equals 1, and we're going to set the last is equal to the max of the last item and the last index. With that, and we get that last point where if I is equal to last, then size is equal to 0 and result is plus dot append size, actually. So the size needs to happen first before we reset, and with that we can return the results. Perfect, and let's submit. great. This is a pretty good solution. I think this is pretty good. And I hope you learned something today. And what we learned today was, well, find out what the limitations are for your problem, and using that piece of information, you can solve the problem. And that limitation here today was the last index of the character. And once we got past that, we're good to go. So that's all. If you enjoyed this video, please like and subscribe. If you want more videos, check the link in the description below. Thank you very much, and I'll see you in the next one.